In this video, we're going to talk about science communication. Because really, when you're working with a lot of data and you want to communicate it to the reader, you're often going to communicate it either as a figure or as a table. Figures and tables are great because you can put a lot of data into them, and sometimes they're a lot easier for people to interpret and to get to the point of the data than just reading a very long description of the data in your paper. That being said, it's pretty easy to make bad figures and tables that are hard for the reader to interpret or to understand. So we're going to talk about some rules for making good figures and good tables. First up, we're going to talk about a table. So a table is just a matrix with rows and columns that have labels, and the data is in the matrix somewhere. And we'll take a look at some examples soon. Tables always have a short descriptive title, and they should be numbered. So they should be table 1, should be the first table. The second table you talk about should be table 2. And there should be some sort of description next to that above the table as to what is actually in that table. As I said, tables should appear in the text in the order in which they are numbered. So whatever table you want to be first, you want to talk about first, should be table 1. And whatever table you want to talk about third should be table 3. And they should appear in the manuscript that way. It can be tempting to make the font size of tables really small so that you can fit a lot of data on there, but that is going to make it really difficult for whoever is reading that to be able to see what the numbers are, or letters if it's some sort of descriptive or qualitative data. So you want to make sure that you have at least 11 points on your font, and it's a standard font like Helvetica, Times New Roman, Cambria. You want to stay away from Comic Sans or any of those funky fonts because they're just going to be really hard to read. You want to make sure that there's white space is minimized, so there aren't like big giant margins if unnecessary. It just looks awkward. You want your reader focusing on the data, not on the aesthetics of your table, because they're distracted by all this extra white space. You make sure that you have labels for every column and every row, and in those labels there should also be the units. So is it pounds, ounces, kilograms, micrograms, lumens if you're dealing with light? Make sure that that is next to the label and that it's in parentheses, so that's kind of clear that those are the units. Let's look at a bad table. Here we have a table where it doesn't even seem all the data is there. There's no phosphate or methane data. Each type of data also has multiple averages and standard deviations. So what's going on there? Averages of what? There's no units for the radium or nitrate or phosphate or methane, so we don't know if these are all in the same units or if they're not. Spoiler alert, they're not. Radium is usually measured in radioactivity, which is a different unit than, say, silicate or nitrate, which might be measured in concentration or mass. So overall, this table is just difficult to interpret. We don't even know, there's no title here telling us where this data came from. So let's look at a better version of this table. Here we go. So now we have our descriptive title at the top. This is table 1. Okay, so this will be the first table in the data. And we can see that this is solutes and different water types at site 1. Presumably, there's some map in the paper that also shows where site 1 is located. And we can see that we have different averages because we have different types of water. We got groundwater, ocean water, and river water that are being compared. The empty rows with no data in them have been deleted. We also made the table bigger so it's easier to see, and we put units on the radium and the nutrients. So we can see radium is measured in becquerels per liter, so that's radioactivity per liter, and silicate and nitrate are measured in concentration. So this is a much better version of a table. And you can always ask, when you're making a table, ask someone around sitting next to you, mom or dad or a friend, hey, can you tell what's going on here? If the answer is no, it means you need to go back and revise it a bit. Now let's look at rules for figures. Figures are great because really figures, you can cram a lot of data into them and they're really easy to interpret. So if you think of visually, if you have 2 sticks, you can see which stick is longer. Then it would be a lot faster to interpret and say, hey, that stick's longer than if you knew that one stick had a length of 7 inches and the other stick had a length of 9 inches. It's just a lot faster to visually see it. Think about a family member or friend that you have and describe what they look like in your head. If you're going to describe what they look like to another person, that's going to take a lot longer than just showing them a photo of that family member or that friend. So figures are very helpful when you're showing your data. As with tables, figures should be named and numbered as figure 1, figure 2, figure 3. Figure 1 should come first in the manuscript or in your essay when you're writing about it. Figure 2 should come after figure 1, and so on and so forth through as many figures as you have. Again, you want to make sure that the font is really easy to read on those figures. So we want a nice big font size of at least 11 and some standard fonts like Helvetica, Times New Roman, or Cambria again. Really make those figures easy, those letters easy to see. It's actually when you're making a figure, it's pretty easy to accidentally make all this stuff too small and you have to go back and start over, so make sure it's nice and big from the beginning. Each axis should be properly labeled, and you should have, again, units following the label in parentheses. Mass, pounds, lumens, inches, whatever units are, they should be following that axis. You want to make sure that grid lines should be turned off. A lot of software systems, like Excel, will automatically put grid lines on your table. They just make it look really busy, and they can also make it hard for you to focus on the actual data. So you want to first thing you should do is get rid of those grid lines. Figures must be accompanied by a descriptive caption at the bottom of the figure. So underneath the figure should be, a sentence to 5 sentences describing what is in the figure. And the captions should be so long and so descriptive that you can actually tell what's going on in the figure without having to go look in the manuscript or the body of the text to see what's going on. You want to also make sure that the plot size is nice and big relative to the space of the figure. I'll show you what that looks like in the next following examples. Generally, if you're putting a symbol on the plot, you want to make sure it's unfilled. If you have a bunch of little circles and they're filled with a color, it's hard to tell how many circles are in one little cluster. But if you have just the outline of the circle, it's a lot easier to count how many circles are in that location. Also, you want to avoid smoothing when you're working with a line plot. So this is smoothing is some sort of algorithm that your software system may allow you to do to make the lines look nice and curvy and fitting well together, but also kind of manifests fake data. So you want to avoid smoothing to show that you're being true to your data. Let's look at some components of the figure. You can see here that we have little triangles and squares. Those are the data points. And you can see those are what we're talking about. We're talking about markers. Sometimes they're called markers or symbols. The y-axis, which has both numbers on it showing what the values are. And then also you can see the cumulative germination, that's the axis label. And percent is the unit. So that's there in those little parentheses. You can also see below the figure, here's called a legend. We can also call it a descriptive caption. This is figure 1. And it has a couple of sentences there explaining what is in the figure. There's also a legend on this figure, or in this case it's called a key, which shows what those different symbols mean. And we can see that all the numbers are nice and big, and we can very easily read this figure. This is a bad figure. When I was talking about you want the plot size to be maximized, that is not what is going on here. The plot size, which is that gray space, is scrunched down really far, so we can't really see what's going on with the data. Also, if you look at the legend on the right-hand side, it's really small, so kind of hard to see and pull out what these different symbols mean. You also see that these symbols are filled, so we have triangles, diamonds, and squares, and they are filled with color. So it's kind of hard if you look at that cluster of pink squares down there in the lower left-hand corner, how many squares are there, because they're all just melding together. This is a better version of that same figure. So here we have the figure area nice and big so that we can see a little bit more what's going on with the data because it's more spread out. The legend is larger, the font of the legend, so we can easily read it. Since we can see just the outlines now of the symbols, they're not filled with color. It's a lot easier to see that there are a lot of squares in that little corner. So it's not just 4 squares, it's probably a lot more than that. Also, now we have a figure caption below it. So you see this figure 1, and we can see that this is radium, concentration or activity for different water types at this specific beach, which is actually a beach in California. So one last thing I want to touch on, which is a note about publishing. When you go to publish a figure as part of any sort of publication, color is usually a lot more expensive. So it's in your best interest to try to make everything look good in grayscale, so black, white, or gray. This has the added benefit that people who are colorblind, if you can design it to be basically a colorblind figure, they're going to be able to see what's going on. Versus if you're only relying on symbols that are different colors, well, to a colorblind person, they may all look the same. So you want to make sure you have a variety of symbols, circles, squares, etc., and that it's easy if you print it out in grayscale, you can still see what's going on. Data is better represented in a figure than a table, if possible. Sometimes this is not possible, but if you can, try to make it a figure. Certain file types are optimized for print, so this is generally TIFF and PDF, and others are optimized for a computer screen, such as a JPEG. So depending on where you're going to show this figure, you want to save it as a different file type. If you're going to actually print this out, you want to make sure that there is a minimum DPI of 1000 for black and white and lower for color and photos. This is to make sure that it's not all blurry when you print it out. If you're going to use someone else's figures, you got to get permission from that resource to do so. So if you are using an open access figure or something in the public domain, you generally don't have to ask for permission, but if it's copyrighted in some way, which a lot of scientific figures are that are used in papers or published in journals, you need to go get permission to do so. There's usually instructions for how to do so on the journal's website. Every journal company will have specifics to follow that they want you to follow when you're making a figure. So that might be how big it should be, or what DPI it should be, or certain things you should or should not do. And you want to take a look at that. That should be under the guide for authors on the journal or publication's website.